All right, Auto One, we're going to be talking today about the four-stroke cycle of an internal combustion engine. And what you've got in this video, it's showing us the, put the camera up just a little bit. It's showing us the crankshaft and the pistons and everything working together to make that internal combustion engine work. So here's a section of the crankshaft, a connecting rod, and a piston with two exhaust valves and two intake valves. That's a fuel injector. The blue is air going in. This is a spark plug. So air and fuel go in, we compress it, we get a spark, explode, push the piston down, and we expel it. So we're going to go ahead and talk about all the parts that are involved in this four-stroke cycle right now. And so we'll begin looking at the PowerPoint. So let's do that right now. All right, so let's talk about the four-stroke cycle components. First, we have the engine block or cylinder block that houses the cylinders and internal parts. So you can see 1 hole, 2, 3, 4. So you're seeing 4 cylinders. And similar, if you just look down here, there's an engine block right there with 6 cylinders, 6 holes. That's an aluminum 99 Toyota, or sorry, Lexus RX 300, 300. And anyways, so the cylinder block is the main foundational part of the engine that has the cylinders and the internal parts that go in those cylinders, pistons, rings, connecting rods, etc. So next component that we're going to think about is the cylinder itself. It's a round hole in the cylinder. We call it a bore, okay, in the block, and for the piston go up and down. And what you're looking at here is these fine hair-like scratches that you probably can't see too well in the video, but that's what we call a honing mark or a cross-hatching. But the cylinder block houses the cylinders. The cylinders actually are the hole for the piston. The next, what we have is the deck of the block. And the deck of the block, all right, so the deck of the block is the top surface of the engine block. That's where the cylinder head bolts on, and these are actually 1, 2, 3, 4, 5, 6, 7, 8 cylinder head bolt holes. These other ones are passages for coolant to flow from the block up to the head for cooling. Next, we have water jackets in the block, and that's the cavities that I was just referring to. And those passages extract heat from the cylinder in the combustion chamber and take it up to the radiator where air passes through the radiator, cools off the coolant, and the coolant comes back to the engine. The core plugs or freeze plugs are these discs on the side of the block here, and they seal the holes left in the block after casting. So they make this as a sand casting. They've got to get the sand out of there, so there's a void in there for the water jacket to have water in it. So they have to have a hole, then they've got to seal it up. They call it a freeze plug because if you live in Minnesota or something in the wintertime and it freezes, you don't want the block to expand because of freezing, because that's what happens when you freeze, the water expands. I shouldn't say the block expands, but the water expands. And if you don't have a high enough percentage of coolant, it will break the block. Well, with the freeze plugs, it pops those out, and that obviously is a lot cheaper repair to put those back in. If we keep the coolant like we should in our climate at 50-50, 50% antifreeze, 50% water, then none of this is an issue. Okay, let's keep going further. So in the block, we have what's called main bearing bores, and these are holes, for the crankshaft and the bearings. So this hole here, 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 here is where the crankshaft rides in the engine. And I'll move the camera over here to the table so you can see, if I can. Okay, so I'll move this camera down here to see the crankshaft. So there's the crankshaft sitting here on the table, and I'll stand it up. And so this round part here, 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 and here are going to bolt into the back of this block here. And so these holes are a hole, again we call it a bore, but this bore is going to, sorry, I gotta get this guy back in there. Anyways, those 4 holes go around here, and we call these main bearing bores. They're the holes for the crankshaft and the bearings, and these are the bearings They're called insert bearings. I'll come up here in just a moment. So next we have main caps. The main cap forms the top portion of the main bearing bore. And you can see on this Chevy V8 engine, there's 5 main caps. These are going to hold the crankshaft in place. So these 5 main bearing cap are going to bolt the crankshaft down so it can spin really, really true. And again, it's spinning at freeway speeds at 70 miles an hour at about 30 times a second. Okay, so we'll go forward here. So the engine bearings are soft wearable inserts, and these are the engine bearings for the crankshaft. And so these bearings, these are main bearings off a Chevrolet V8. Here's a giant Caterpillar main bearing. And you can see there's holes where oil comes up through, and the oil spreads out on the surface here. And then the crankshaft's basically floating on a sheet of pressurized oil. The groove is so that oil can go to other parts in the engine. This is a Chevy 350, what we call this main thrust bearing. Again, these are insert bearings. You guys are probably used to ball bearings and tapered roller bearings from ball bearings would be in like skateboard wheels, etc. But these are what we call insert bearings. They have a lot more surface contact. They can handle a lot more load. And if we spread out a sheet of pressurized oil, that crankshaft can spin at 50 times a second and have virtually no friction, very little. So we call them insert bearings. Okay, they're tri-metal. They're a layered metal. They have a hard steel backing, and then they have some softer metals to give a nice soft wearable surface for the crankshaft. There are what we call main and rod bearings, and again, this is a connecting rod right here. This is a connecting rod, just like what's in the picture there, over here. And there's a bearing that goes in here, and it's 2 halves, and that's what keeps, is this thing spinning around and around like that, keeps it with a nice thin pressurized oil barrier so the crankshaft doesn't get damaged on that. So next is the piston, which is this guy here that's going to transfer the combustion energy of the explosion of air and fuel to push that piston down and push the connecting rod down and around. So the piston's going up and down, or what we call back and forth, which is a reciprocating motion. And the big end of the rod, this here, is spinning in what we call a rotary motion. Okay. So the piston is what's going to harness the energy of the exploding gasoline and oxygen and connect that energy to the crankshaft. The piston rings over here are going to seal the gap between the piston itself and the cylinder wall. On gasoline engines, you have 2 compression rings and 1 oil control ring. And I'll come up on the next slide, I believe, or as soon as, yeah. So here's our compression rings. These are the 2 top rings that are going to seal combustion gases. So up here on top of the piston, we have air and fuel. We get a spark, it explodes, it forces the piston down. These are your seals, so that it doesn't go, the gases don't get by the piston. The gases getting past the rings in the crankcase, we call them blow-by vapors, okay? Because it's just vapors, combustion vapors that are blowing by the rings. So that's compression rings. Next is oil control rings. This is a 3-part oil scraper that as the piston goes down in the cylinder, it's going to scrape oil off the cylinder walls, and that'll drop into the oil pan. Call it an oil control ring. Oil bypassing, like it says right here, is going to burn in the combustion chamber. So if these are worn, oil will get past, go up here, it'll burn in the combustion chamber, and you'll probably see blue smoke out the tailpipe. Okay, so when we see blue smoke out the tailpipe, we're thinking oil burning. If we see black smoke out the tailpipe, we're thinking too much fuel. And if we see big clouds of white smoke, we're thinking there's coolant or water in the combustion chamber. So next is the crankshaft. There it is. And this one happens to be a 1, 2, 3, 4 cylinder crankshaft. This is the device that's going to change reciprocating motion into useful rotary motion. When I say useful, because remember the wheels are spinning in a rotational motion. So the whole goal of that engine is turn the exploding, pushing down motion of the piston, called the reciprocation, into a rotational motion. Next is the main journals, which is this round part of the crankshaft So we got 1, 2, 3, 4, 5. You can't really see that one up there. But those 5 journals are the round parts of the crankshaft that are going to be where the crankshaft spins inside the block. And so again, I'll dip the camera down here and you can see this crankshaft. And this is a 6-cylinder crankshaft. It has 1, 2, 3, 4 main journals, this round machine surface where the crankshaft spins in the engine block. And then we have rod journals, and that's where the connecting rods, and here's the connecting rod here, and this is one of the pistons and connecting rods for this engine. That's where this rod is going to connect onto there, okay? And there's supposed to be insert bearings in here. And so we have 1, 2, 3, 4, 5, 6 connecting rods on that 6-cylinder crankshaft, okay? All right. So next are counterweights. So these counterweights are these funny looking guys here and here. They are opposite the piston rod. So when the piston rod go up, that's a lot of weight being thrown up into the top of the engine. We have to have a counterweight being thrown down to offset that for engine vibration. So these are the counterweights here, 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 and here. Okay. After this, we have the connecting rods themselves. They're going to connect the piston to the crankshaft. So here you go. Here's a connecting rod. We say this is the rod's small end. You can see where the small end where it attaches to the piston, and there's the rod big end, and there's the bolts that we've got loose right now, and the insert bearings are out of there at the moment. Okay, that's a pretty special piston. All right, so that's all the parts. What we're just talking about there is all the parts for the lower end of the engine. Now we're going to look at the upper end of the engine. First, the cylinder head. The cylinder head is the second of 2 main foundational pieces of an engine. Every engine main foundational piece is a cylinder block and a cylinder head. And if it's a V6 or V8, it's got 2 cylinder heads. So here's a 3-valve per cylinder head for an old school or older Honda. Here on my table, if you just put the camera down there, here is a 1-cylinder head off of V6. So this is 1 combustion chamber for 1 cylinder, another, and another. So 3 cylinders. But there's 2 of these heads for that V6 engine. These are the smaller valves of the exhaust valve, the larger valves of the intake valves. But this cylinder head forms the top portion of the engine. It covers the cylinders, and it also holds and houses the valve. So this is kind of interesting. What do you suppose that cylinder head is for? Well, it's got 2 combustion chambers, one here and one here, so it's covering 2 cylinders. So that could be maybe an old school Volkswagen or Porsche. In this case, it is water cooled. You can tell it has water jackets. This is actually a Subaru. So almost all Subarus are horizontally opposed or flat engines, we call them. 1 cylinder head covers 2 cylinders. The other cylinder head covers another 2 cylinders. This has 2 exhaust valves, 2 intake valves, and the Subaru uses this in everything. All the Outbacks use it, except there is a horizontally opposed 6-cylinder version of the Outback. There's just not that many of them around. The bottom one down here is an old school American engine, 1 large intake valve, 1 smaller exhaust valve. There's a spark plug, and there's a combustion chamber covering a cylinder. The combustion chamber is this area right here where the air and fuel burns. It's ignited by the spark plug right here. So we say it's the cavity where combustion occurs. That explosion, which is a controlled explosion, we create that just to push that piston down inside the cylinder. So we have to have ways of getting the air and fuel in. We have to have ways of getting the burned exhaust out in that 4-stroke cycle. So we go down with intake valve open, we suck in fresh air and fuel. We go up with both valves closed. We compress the air-fuel mixture into a very explosive mixture. We get a spark, we explode and push the piston down, and then the piston goes up with the exhaust valve open to expel burned exhaust gases. So the valves open and close to let air and fuel in and to let exhaust gases out, and there's some valves there. And then down here on the table, I've got all kinds of valve samples, and these ones with the blue tags they're bent or they're burned, and I'll put this one up here so you can see it's all eaten away right here. Okay. This is a top fuel dragster titanium valve that bent. Okay, the valves hit the piston. Pistons always win when they play tag. So the valve spring is this spring that's used to close the valve. And I would say to you, when I don't have the camera pointing in the right place, you should yell at me, but I won't be able to hear you. So anyways, so this valve spring is used to, once the valve goes down, the spring's gonna close it back up at the right time. Okay, when in working in conjunction with what's called the camshaft, which will come up, I believe, next. So here comes the camshaft. So this funny looking eccentric lobe shaft is what's used to open all the intake valves, open all the exhaust valves. So I've got a camshaft here in my hand, and this is one of the what we call roller cams that goes in that cylinder head that I just showed you on the bench there. So this one has 2, 4, 6 eccentric lobes, and eccentric because they're oblong. They're not concentric. They're not a perfect circle. They're oblong. Okay, so that's a camshaft there. This engine's going to have 4 of these, 2 intake camshafts, 1 on each cylinder head, 2 exhaust camshafts, 1 on each cylinder head. They're going to create the motion to push the valve down and open, and then the valve spring's going to close the valve after the cam lobe comes around. And located in the block on all old school pushrod engines or flathead engines and everything modern, they're in the cylinder head, or we say they're overhead cam. So this cylinder head here on the bench, this Duratec V6, if I flip it around, you should be able to see where one camshaft bolts under those caps and the other camshaft bolts under these caps. Okay, so back up here. The cam lobes, these eccentric lobes, like you can see in the picture, are what push down on the valves. Okay, so we call the valve train components all of those components that are involved in opening the valve. Call it a train because, like a train, they're all connected one after the other. So this picture shows an old school pushrod engine, what we call an overhead valve engine. Here's the eccentric lobe of the cam, pushing on what's called a hydraulic lifter or a tappet, pushing on a pushrod, actuating a rocker arm, and pushing down the valve. So all of these are valve train components. They're components that are involved in opening the valve. So we have a camshaft, and we have, here's the camshaft, some sort of valve lifter or tappet. We have a pushrod, if it's a pushrod style engine, non-overhead cam, and we're going to have rocker arms there. And those are all the parts that are involved in opening the valves. So in addition to that, here's a picture of an overhead cam engine just for comparison, where the cam lobe just pushes down on this bucket or this cam follower and opens the valve. Here you've got all these components opening the valve. This one's going to accelerate more quickly, has less friction, less weight, etc. So that's what the design that we pretty much use in everything today. Not everything, but most everything. So we're almost done here with our engine parts. Intake manifold is going to carry air from the air filter to the cylinder heads. This one here is an aluminum intake, and most of them are aluminum today. They used to be cast iron. Some are even plastic, at least the upper part. If it has an upper plastic intake manifold, then it's probably got a lower aluminum part. That's going to carry air and fuel into the cylinders. The exhaust manifold here is going to take the burned exhaust gases and take them out of from the cylinder head and then down to the exhaust system, which would be the pipe, the catalytic converter, a muffler, a resonator, etc., and then out the back of the car. So we're going to carry burned exhaust gases from the cylinder head to the catalytic converter and to the muffler. Catalytic converters are a little chemistry unit that's going to help convert things like carbon monoxide into CO2, hydrocarbons into H2O, and we'll just expel nitrogen as well. We'll strip oxygen off of nitrogen. But this exhaust manifold here is what we call a header because we have individual exhaust runners. It'll tend to make more power, or at least more horsepower, than one where they're all kind of combined into one unit. So finally, the last set of components is what we call the timing gears, chain, or timing belt. Devices that are used to connect the camshaft and the crankshaft together. So the crankshaft here on this American V8 engine right down here has to spin that camshaft, and we're going to spin it at 1/2 crankshaft speed. So hence you've got a 2-to-1 ratio between the gears. So the crankshaft spins twice, the camshaft spins once. That's because The crankshaft down here goes down, that's half a turn, that's intake, compression, and then power, and then exhaust. The camshaft opens the intake and exhaust valves, so that's one rotation of the cam. The crankshaft did two rotations, okay? So it's a 2-to-1 ratio. This is an older American V8 with a chain type connection, chain and gears. Here's a 90s, like a Honda, with a rubber timing belt that we thought, oh, this is cool. It's quiet, it's cheap to manufacture, it's lighter, and so that helps us meet gas mileage standards and things like that. But they break and they have to be replaced, usually every 90,000 or some 120,000 miles. So this was, 50s, 60s, 70s, 80s, this was 90s. And then in the new millennium, we about 2004 or 5, we started going back to chains, because customers, it's really hard to convince a customer they need this $400 timing belt replacement when the engine's running fine. So now everybody's gone back to chains, and pretty complex, because I've got 2 camshafts on each cylinder head. I've got these oil pressure guide rails to keep tension on that chain, because the relationship between the crankshaft and camshafts is absolutely critical for the running of the engine. That's a cover to cover those parts of, okay? So we'll take a few minutes to talk about the 4-stroke cycle, and then what we're going to do is I'll do another demonstration where I go over in the shop and I show you a running engine, and you'll kind of feel the compression and everything, hear the engine run with no exhaust. So it's kind of fun. So when we go to start an engine, we're going to start it with either a key start or a push button. And when we push the button or turn the key to the crank position, we're sending battery power to the starter motor, which pushes this little gear on the starter motor out, engages this big flywheel ring gear, which is bolted to the back of the crankshaft, and we start turning the crankshaft over and initiating that intake, compression, power, exhaust 4-stroke cycle. You can see this has 4 pistons. That's what we call an inline 4-cylinder. So the first stroke of an engine is called the intake stroke. So a 4-stroke cycle engine, it has 4 separate events, if you will. The intake stroke is the downward motion of the piston. That's drawing in air and fuel into the cylinder, mixed at a ratio of about 14.7 pounds of air to 1 pound of air. So 14.7, sorry, I did that wrong. 14.7 14.7 pounds of air to 1 pound of fuel, okay, is our ratio. All right, let's hold on here. All right, we're good. Sorry about that little hiccup. So 14.7 pounds of air to 1 pound of fuel is what we call our stoichiometric or chemically correct air-fuel ratio, or ideal air-fuel ratio at sea level, okay? Engines run best at this approximately this ratio at sea level. As you go up in the atmosphere, we have to change that ratio, and we have to make it leaner. We have to make it more like 15, 16 to 1 anyways. Okay, so the intake stroke, the piston's going down, it's drawing in the air and fuel. So the crankshaft spinning half a revolution, the piston travels from top dead center to bottom dead center, and the air and fuel gets sucked in through the open intake valve. Next is the compression stroke. The compression stroke, the piston starts at what we call bottom dead center, and the crankshaft comes around, it pushes the piston up. So the second 180-degree revolution is the compression stroke. Now we're going to squeeze the air and fuel into about 1/9 of its original volume. We would say that the engine has a 9-to-1 compression ratio in that case. It could have a 10-to-1 or even 11-to-1 air-fuel ratio, but a 9-to-1, 10-to-1 is a pretty common air-fuel ratio. And so as we squeeze that air and fuel into that very tight volume, the molecules of air and fuel rub each other, cause friction. The heat of combustion goes way up. We get the spark, and we get quite an explosion. That's the compression stroke. The third stroke is the power stroke, and the power stroke begins with a spark right at the end of the compression stroke that starts igniting the air and fuel and those compressed gases, and the explosion is going to push the piston down. The piston starts at top dead center, and it's coming around down to bottom dead center, and this is the third of the 4 strokes. the burn gases are going to expand and force the piston down, harnessing energy. So of those 4 strokes, only one of them is actually a power producing stroke, and that's the stroke that's going to give energy to propel the car down the road. The 4th and final stroke is the exhaust stroke. Now burn gases are going to be pushed out of the engine. So the piston starts at bottom dead center. Its last 180-degree revolution, it's pushing the piston up, and the exhaust valves open, and we're going to expel those burned exhaust gases into the exhaust system. What's going to come out of here, ideally, we hope, is CO2 and H2O. In reality, we get some unburned hydrocarbons, we get some carbon monoxide, we get some oxides of nitrogen, and we will treat most of those that we do get out of there in the catalytic converter. So those are the 4 strokes: intake, compression, power, exhaust. Intake, we suck in air and fuel. Compression, the intake valves open. Compression, we close both valves and compress into about 1/9 of its original volume, making it really hot. We get a spark. It explodes. We push the piston down on the power stroke, and then we open the exhaust valve. As the piston goes up, we expel the burned exhaust vapors. Okay, so that's our 4-stroke cycle. So what I'm going to do next is I'll have a demonstration set up in the other shop where we are going to feel compression, and then we'll crank the engine, and then we'll start the engine, etc.